Hello and welcome to this course on Introduction to Statistics and how it is applied to analytics. So in this course I'll give you some basic understanding of distributions. So basically the probability distribution that is a frequently used topic in the field of data analytics. In this I'll tell you about important distributions, what their properties are and how they can be applied to solve problems. The prerequisites for this course is understanding of discrete and continuous variables and how to calculate mean and median and probability theory. So some basic understanding of probability is required for this course, and that will help you in understanding various distributions and applying those distributions to actual real life problems. So if you want, you can refer to the Stat 101 lecture, which talks about discrete and continuous variables and mean and median, and there is a separate lecture on probability theory that you can go through in order to get a better understanding of probability. So now let's come on to the topic for this lecture, that is probability distribution. So what is probability distribution? It has basically three parts. One is probability distribution is basically a graphical representation that lists all possible outcomes of a sample space along with its associated probabilities. So let's take a very basic example to illustrate this point. So let's say I toss a coin, and what are the outcomes? It can be head or tail, and what are the probabilities of head and what is the probability of tail? So it's 50-50 chance, right? So the probability of head is 0.5 and a probability of tail is 0.5. So there's a basic example, and you can see that you can easily calculate head and tail. That is basically the numerator is if there are two possibilities, the possibility of head is 1 by 2. So denominator is basically the sum of all the possibilities. So here it is 2, and the numerator is head or tail, so 1 each. So 1 by 2 is the probability. Now if we make it a little more complex, so here I can see that the outcomes in a sample space are head or tail. So outcomes in a sample space is just a fancy way of saying what are all the possibilities. So basically you list down all possible outcomes and that's your sample space. Now if I dig into this coin toss example a bit, what happens? So if I am not just tossing once but I'm tossing twice, so there are then three possibilities. In this case there are, if I toss twice, then the possibilities of head are either I can get 0 heads, that is both the times I get tail, or there can be 1 head and 1 tail, and there can be 2 heads. So the outcome of getting a head can be 0, 1 and 2. So in our one coin toss example there were basically 2 outcomes, 0 and 1. So basically 0 head and 1 head. But in case of 2 coin tosses there are 4 outcomes. What are they? Both are head, 1 head 1 tail, 1 tail 1 head, and both are tail. So this is basically the order. So if the first one is head and the second one is tail, that is one possibility. If the first one is tail, the second one is head, that is another possibility. So that's how we get 4 different possibilities. So now the possibility of getting both head is just 1 out of 4. So the probability of getting 2 heads is 0.25, and possibility of getting 1 head and 1 tail, just because it can happen in two different ways. First is head, second is tail, or first is tail, second is head. So we have 2 out of 4. So it is basically 2 into 0.25 or 2 by 4, which is 0.5, and again getting 2 tails or 0 head is 0.25. So these are different outcomes, and we are basically showing, if we just draw a plot of this, all the different outcomes, and show how this behaves. So that is basically our probability distribution. So we are distributing the probability. We are saying that it can be 0.25. So for our probability distribution, we need what probability we are measuring. So here we are measuring the success, and we define success as getting ahead. So if we define success as getting ahead, then what are the success chances? So it can 0.25 of the possibility of getting 2 heads, 2 into 0.25, that is possibility of getting 1 head, and 0.25 of possibility of getting 0 head. So there are three different possibilities, and that's how we plot it. So the plot will look like 3 bars basically. So in a similar way, we can toss the coin 3 times, 4 times, or 5 times. If we toss the coin 3 times, there are 4 possibilities, 4 different values of head that you can get: 0, 1, 2, 3. If you toss it 4 times, you can get 0, 1, 2, 3, 4. And if you toss it 5 times, we get 0, 1, 2, 3, 4, and 5. This many heads we can get. So, but the outcomes, the sample space is changing. So if you toss 2 times, there are 4 different outcomes. If you toss 3 times, there are 8 different outcomes, because each can be head or tail. So 2 outcomes per toss, and then 2 into 2 into 2 is 8. Similarly, for 4 tosses, there are 16 outcomes, and for 5 there are 32 outcomes. Now let's go to the next slide and see how it works. So I'll show you some equations now. So if we extend our logic in the previous table to more than one coin tosses, instead we'll get this. So probability of 0 head is basically 5C0, 0.5 to the power 0, 0.5 to the power 5. What this means is there are 5 ways in which 0 head can appear. There's only one way in which a 0 head can appear, and the probability of getting 0 heads is 0.5 to the power 0, because in this case all the outcomes are tails. So 0.5 to the power 5. So each outcome has probability of half. There are 5 possibilities. So 0.5 to the power 0, that is head to the power 0 and tail to the power 5. In this case, since head and tail both have probability of 0.5, we can see that both the terms here are 0.5. If let's say it was a biased coin and probability of head was 0.7 and probability of tail was 0.3, then it would be 0.7 to the power 0 into 0.3 to the power 5. But in this case it's a fair coin, so I will show it as 0.5 to the power 0 and 0.5 to the power 5, that is this. So there is the chance of getting 0 heads. Chance of getting 1 head is 0.5 to the power 1 and 0.5 to the power 4. So you can see that the sum of these two exponents are always 5, because we are tossing the coin 5 times. So 0 plus 5 is 5, 1 plus 4 is 5, 2 plus 3 is 5, 3 plus 2 is 5. So basically what is happening is, if I make this 0, this will be 5. If I make this 1, this will be 4, 2, 3, 3, 2, 4, 1, 5, 0. So these are 5 coin tosses and 5 different probabilities of getting 0, 1, 2, 3, 4 and 5 heads. Now this is what we call as binomial distribution. So binomial distribution is a probability distribution for a random variable x which can take only two discrete values. Now a lot of jargons here. What is random variable and what are discrete values? So I'll explain that. So the problem that we discussed just now had these different values. So this is the probability of getting 0 head. We calculated it as 0.03125, 0.03125. Then probability of getting 1 head was calculated as 15625. This is 15625. Then 2 heads was 0.3125. This is 0.3125 and so on. And this is the probability of getting 5 heads. So now if I equate all these, we'll get the values that we discussed. So I've simply just plotted all the values that I'm getting from these probability equations, and this is what we get as a binomial distribution. Why it is called binomial distribution? Because every coin toss is an event, or it's an observation, and it has two possibilities, 0 and 1, or head and tail in this case. So that's why we call it binary or binomial. Now if we move one level, then I can say that instead of 5 coin tosses I can do 10 coin tosses, and then this distribution will look a little different. It will become like this. So more coin tosses we do, it will tend to be a normal curve. So I'll come back to normal curve a little later, but that's how it will look like. This is how normal curve looks like, and it is the same curve that we get if our binomial distribution has a lot of observations. So a binomial distribution is always represented by these two values. So one is the number of observations, so how many coin tosses are happening, or if we are doing some other random if we have some other random variable, like a team is playing a match and it can win or lose a match. So there are two possibilities, either winning or losing. So if the team plays 5 matches, so it is also a binary distribution, and I'll show you how we get the chances of success of the team. And it is also a binary distribution with n is equal to how many matches the team is playing, and p is equal to the probability of winning each match. So that way we can look into it. So n, or number of observation, is fixed in a binary distribution. So whenever we are trying to plot a binary distribution, we should know how many observations will be there. So if we are plotting the coin toss example, we should know how many times we are going to toss the coin before we plot this binomial distribution. And we should also know the probability. So we should know the probability of success for each event, or what's the probability of success for each outcome. So now we know that binomial distribution is a distribution of probability of successful outcome of a random variable. So let's move a bit. First, let's understand what is a random variable. It's nothing but a fancy term for variable that can take multiple unknown values, like head or tail in case of a coin toss. It can be 1, 2, 3, 4, 5, 6 in case of rolling a dice. It can be winning or losing in case of a team playing a match. It can be head in case we are giving a patient a medicine. He can either get cured or not get cured with that medicine. So those are two different possibilities. So we can say that the effect of the medicine is a random variable, and it can be either cure or not cure. So anything that is uncertain, and there can be multiple values associated to that variable, and we don't know what value it can take. It can take any value under different circumstances. We call it a random variable. And if our random variable has only two values, we think of binomial distribution. But it can take more than two values, then we have to consider other distributions that we will discuss later. So in case of our binomial distribution, we are now taking 10 values. So let's start with the theoretical problem. So here in this case, we have what was the probability of 2 or more success in 10 tosses, and what's the probability of 3 or less successes in 10 tosses. So that's something we'll try to work out using Excel. So here in Excel, I'll just type I just take these values. So basically these are different possibilities. So if I'm taking heads, we define like if there are 10 coin tosses, there are 11 possibilities: 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 heads. So these are the values. So now I'll take the C value, that is the combination values that we saw, that the order in which the heads appear can be, so if there is just 0 head, there's just only one possibility, that there is 0 head. But if there is 1 head, that 1 head can be there in the first toss, in the second toss, in the third toss, or in the 10th toss. So there are 10 different possibilities of 1 head. So similarly for 2 heads, there are 45 different possibilities of where those 2 heads are appearing. So that's why these coefficients are like this. And then I'll take the probability. So probability of a head appearing is 0.5 to the power 0 in case of 0 head, 0.5 to the power 1 in case of 1 head, 0.5 to the power 2 in case of 2 heads, and so on and so forth. So that's the probability that we are getting here. So it's basically p to the power, okay, probability to the power number of occurrences. And then the probability of failure. So failure in this case is we are getting a tail. Getting a tail is a failure for us. So probability of failure is, so when probability of head is 0, probability of tail is like this, 0.5 to the power 10 basically. So when the probability of head is 0.5, this is 0.5 to the power 9, and so on. So this is the other half, and then we calculate the probability. So that this is the final probability for each of these terms. So the final probability for 1 head is basically the multiplication of this into this into this. So we get this. So if I multiply B2 into C2 into D2, I get E2. And these are all the different probabilities that are there in the sample space. So we will plot all these, and if I plot all these values, I'll get something, right? So if I plot all these values, I'll get something like this. So you can see here the 0 head has 0.0009 as its probability, 1 head has 0.009 as its probability, and so on. So this is our binomial distribution for case of 10 coin tosses, and each has a probability of 0.5. So now what I'll do, I'll go to that old example and see. So the first question was how to calculate probability of 2 or more successes, 2 or more heads in 10 tosses. So for calculating that, I basically have to find out what are 2 or more successes. So 2 or more successes are there, can be 2 success, 3 success, 4, 5, 6, 7, 8, 9 or 10 success. So I have to add all these probabilities basically. So I have to add 0.4394 plus 0.117 plus 0.205 plus 0.246 plus 0.205 plus 0.117 plus 0.043 plus 0.009 and plus 0.0009. Instead of doing that, I know that all the sum of all these probabilities is 1. Okay, the sum of all these probabilities is 1. So 1 minus this plus this will give me the sum of all these. So I basically do that. So I basically subtract P1 and P0 from 1, that is this and this from 1, and I'll get the probability of 2 or more heads. So that's my answer. So I'll just quickly move on to the next question. How to calculate probability of 3 or less successes? So for 3 or less successes, I know that it is either 3 success or 2 success or 1 success or 0 success. So for that I have to find the sum of this and this and this and this. So basically P1, P0, P1, P2, P3. Okay, so if I find the sum of this four values, I'll get the probability of 3 or less successes. So that's a theoretical understanding of if there are 10 coin tosses, what are the chances of 3 or less successes, or what are the chances of 2 or more successes. Next we'll move on to a real life example. So let's have a look at some more variations in our example, and instead of doing a coin toss, we can say that let's take a biased coin. So this is not a real life example, I'm just modifying the old example and then I'll move on to a real life example. So if let's say if I had a biased coin where the probability of head is 0.9, and remember that probability can be anything as long as it's equal for all observations. So if I'm saying the probability is 0.9, it has to be 0.9 for each of the coin tosses. So in this case, if that is what is happening, then our binomial distribution will look like this. So this is a example with 100 coin tosses, and each coin head is, in each case the probability of head is 0.9. So now let's move on to a real life example where there's a soccer match happening. So with the understanding of sample space, outcomes, associated probabilities that we just saw, let's understand what questions can be answered in the real life with these. Think about the answers to all these questions. So there can be different problems that can be answered with the binomial distribution that we just saw. So what is the probability of a team winning at least 2 matches in a league of 6 matches when the probability of winning each match is 0.7? So consider win and loss as only possible outcomes. So this is something that we can answer using our binomial distribution. Next one is, what is the probability that a newly invested drug will cure 2 people when the chances of it working for a particular symptom is 1 in 3, that is probability is 0.33 when the drug is given to 15 people. So basically in the second problem, just think of it as a coin toss where there is 0.33 probability of head and there are 15 coin tosses. And in the third example, what is the chance of a party winning election in 5 states when polls are taking place in 28 states, and the probability of winning each state is 30%, and each state's poll can be considered independent from each other. So a very important aspect of binomial distribution is each event has to be independent. Like if we are tossing a coin 10 times, each coin toss is independent from the other coin toss. Each coin toss has nothing to do with the outcome of other coin tosses. Similarly, let's say there are different states, 28 different states which are going to poll. Each state is completely independent of others. So, and in each state there is 30% chance of winning. So what is the chance of winning in 5 states in total? So imagine, again, if we equate to our coin toss example, let's say we are tossing the coin 28 times, and each time the probability of head is 30% or 0.3, and then we can just fit into the equation that we just saw and do the Excel calculation and find out the results. So I'll do it for one soccer match example. So let's try and solve this first one with understanding of sample space, and let's see how basically what's the first problem is in 2 matches in a league of 6 matches. So basically there are 6 coin tosses, and out of that at least two should be head. So there can be 2, 3, 4, 5 or 6 heads, and each probability for each is 0.7. So how do we do this? First, create a binomial distribution with 6 observations. Okay, so in our case, if we go to Excel, we go for a binary distribution, and each can be the value of in each can be like this. So in this case, there are 6 observations, so the value of k can be 0, 1, 2, 3, 4, 5, 6. That is, the team can win 0 match, 1 match, 2 match, 3 match, 4 match, 5 match, and 6 matches, right? And this value, how do we calculate this value? This value is calculated using a function called combine function. So there is a combine function in Excel. If we use that, and I'd say total number of matches, so there's 6 matches, and in this particular case I'll first take 0, and then I'll just copy paste this formula for 1, 2, 3, 4, 5, 6. So if you see this one is 6 and 1, this one is 6 and 2, and so on. Now I get the value of probability to the power k. So in this case, the probability of winning each match is what? So probability of winning each match is 0.7. So let's say 0.7 to the power 0. Okay, and then let's copy this formula for all other observations, and this is the probability of losing one match. So this is basically probability of 0.7 to the power 6 minus 0. So when there is this is the probability of winning 0 matches, that means there's the probability of losing 6 matches. So losing 6 matches is, actually it should be 0.3. So 0.3 to the power 6 minus 0, that is 6. And now if I just copy this formula, I get this. So now I just have to multiply all these things. So this into this into this, and this gives me the probability of 0 match winning, and this is the probability of 1 match winning, this is the probability of 2 match winning. So what was our question? Our question was the probability of team winning 2 matches. Okay, so if the team is winning at least 2 matches, it can win at least 2, 3, 4, 5 or 6 matches. So what's the probability? So the probability is basically the sum of 2, 3, 4, 5 and 6. So this is the sum. So basically the team has 98.9% probability of winning 2 or more matches. So the team has 98% chance of winning at least two matches, or that means it can win 2, 3, 4, 5 or 6 matches. So this is our answer. There's 98% probability. So this is basically what I wanted to discuss in this lecture. So in the next lecture we'll show how there can be more distributions which we can understand in order to answer a lot of different questions about different life scenarios. Like we discussed soccer matches, we discussed medicines, we discussed a party winning a poll, but these were all binary distributions. But in real life there can be non-binary situations also. There can be multiple multiple values for a random number, random variable. So we'll discuss what kind of distributions are applicable in those scenarios. So thank you for attending this lecture, and hope to see you in the next lecture. Thank you.